Okay, everybody, and welcome to part 2. In the last episode, you saw the test worked. I have my 9-barrel wall flashing away quite happily, and I mentioned that I have a friend who is a Python programming teacher to a group of us. So what I did next, because I'd been already speaking to him on FaceTime, on Discord, we've been having chats back and forth for a few weeks, he had actually gotten to the point where he'd ordered some LED tape, he'd purchased a Raspberry Pi, and he'd got a little string of tape working at his end. Great, fantastic, thank you very much, good sir. What I now did was I packed all the stuff into a box and drove down to Fleet in Hampshire, which is 3 or so hours away from me, so we could all spend the day together at a hackathon. All of the programming class were invited, and we had a fantastic time. There was lots of food and snacks and coding and music. And about the music. Music is generally copyrighted, so I cannot show you a huge amount of the programming class because of copyright claims. Yay! However, I will show you what I can. And I'll start off with this little briefing that was given to the whole class at the beginning, where we are clearly outlining our desires and cravings. And we'll just see how many of those came true in a bit.
Fellow, Pong, Frogger, a graphics equalizer. You know, because it's a party sensibility on it, right? So we need a little mic to listen to, music.
That'd be pretty cool. Yeah.
Scrolling text, GIFs.
That's the most important thing for me.
You're doing the GIFs, right? We'll handle everything else.
I never got the GIFs working.
Right. Gail does not believe in the idea of the GIFs. But
I'm still concerned that refresh rate.
This was actually something that worried us all for a long time. All of us were talking about it at length, was the delay, the refresh rate. The way these LED tapes work is you have like a little computer chip in each light. So each light receives the signal telling it what to do, and then it passes the instruction on to the next one and the next one and the next one. So if you hear, let's say this is LED 0, computers like to start at 0. This is LED 0. If you've got an instruction for LED number 5, it has to go to LED 0, then 1, then 2, then 3, then 4, then 5. So the instruction has to go through all the others, so each one passes the instruction along. And we were concerned how much of a delay would be added. We read the spec sheet and there was a minute delay. But when we first tried out the code, we did something silly. So the way it worked is we would say, LED 0 is going to be green. Then we're going to send a command to turn it green. Then we're going to say LED 1 is going to be blue. And then we send the command to make it blue. And so on, like a loop. What we didn't realize is what you can do is say LED 1 is red, LED 2 is green, LED 3 is blue, and then you send the command to them all. Because the delay was actually sending the instruction. So this caught us out for weeks on end, going, what do we do, what do we do? We were just back and forth. Will this add too much delay? Will we be able to have 3,000 LEDs scroll gently across? Or will they go slowly line at a time? Turned out, wasn't an issue at all. And we found this out at the hackathon. So thank you, Mr. James. Well, got to hand it to them. They went all in on this. My friends were dedicated and excited about the project, which is wonderful. We had a whole group of people had their own different areas. One person was interested in writing the graphics equalizer so he could visualize the sound. That was quite fun. One person wanted to write a color scroller. The teacher, the chap in red, wanted to write the middleware, and that would be the method by which the public connect with the thing and talk to it and control what's on the screen. Another chap was drawing an alphabet out of pixels and making a text scroller. Another chap was making a little version of Snake, which was quite cool. So everyone had picked something that they were passionate about, that they really wanted to spend time on. I spent most of the day getting the electronics to work and trying to help with coding, just to be told, Dan, your coding's terrible, go away. So that was my day. But by the end of it, the LED wall was working, so we had something to work with. However, what, I hear you ask, are my friends to do when they're helping out with this and they're not in the presence of the LED wall? The answer lay in the JerryCanvas Simulator. The simulator was a web page which represented the JerryCan wall perfectly, and you would send what's known as a JSON request to it, where you had the barrel coordinates and then the red, green, blue value for that barrel. Okay, so what that means is you write some code, you send the values and the coordinates of the brightnesses and all that to this piece of software, and in your web browser you get to see a bunch of cubes light up showing you what the wall would look like. Yes! So that means everyone can now write code without having to have 200 JerryCans in their house. Brilliant! So what you're seeing here is the graphic equalizer in its infancy. It's command line based. You see me screaming at it. Bass, mid, etc. That shows the levels of each of the different frequencies. So once we've got that data, it may look like equals signs, but once we've got that data, we can then turn it into something pretty for the barrel wall. So more to be done on this one in the next part. Now what we're seeing here is the barrels are starting to light up in pretty colours now that my friends have started making it do lovely things, which is absolutely fantastic. And now it has become 2 o'clock in the morning. All my friends have gone. It's just the teacher Yale and myself gathered together, making the important bit that I mentioned in the last video, the calibration tool. This is how we will map LED number 1, 2 and 3 to that barrel, and LEDs number 7, 8 and 9 to that barrel. This is how we build it out. We made a file full of coordinates, and it said row 0, barrel 0, 1, 2, 3, 4, and barrel 0, 0 has LEDs number 5, 6 and 7, and so on. So every single barrel would have LEDs attached to it in a configuration file, and another piece of software was then written by him, not me, that would attach these together. So I could just sit at a computer and go, next barrel, yes, next LED attached to this barrel, next LED attached to this barrel, and so on and so on.
All right, so the next one is this missing one here, which is 49, 48, 47.
So it's 1, 0.
Fire them up. Close. These three are the same colour-ish.
Okay, so the overall topology of the system, once we'd got it all built, it was thus. Okay, so I think this all makes some form of reasonable sense here. Okay, this is the diagram that we used. So the public, the members of the public, would interact with a Discord bot. That was made by one separate piece of Python code which ran continually in the background on the Raspberry Pi as what's known as a service. So it was always running. That would then talk to the controller. The controller's job was then to run different Python scripts depending on what needed to be done. So when we told it to, using a command on Discord, we would say run the graphics equalizer, and it would execute that. It would then cycle between clock, text, color scroll, clock, text, color scroll. If there was no text, it could just say no text. And then it also had an attempt at Connect 4, which it didn't work so beautifully in the end, but that's okay. That's how it all worked. That's the whole system. Behold its loveliness. Okay, so that's how all the pieces of code fit together. On the whole, it all works quite well, but we've still only got a 3x3 grid and a simulator. In real time, there was about 1 week between this hackathon and the next video, my birthday. At my birthday party, I invited a bunch of friends over, we all played board games, had drinks, and some of the code a lot really wanted to have a play with this. So I went out and I ordered 200 more JerryCans, all delivered to my office. Now, my birthday was taking place at a spare room at the business centre where my office is at, so we had now 210 JerryCans in our collection. That is enough for a 21 wide by 10 tall grid, which is 3 meters tall and 5 meters wide, which is just enough to use all the LED tape. That is going to be the next part where you're going to see the first time we actually get this wall starting to spring into life. In the meantime, if you have any questions whatsoever, anything you'd like to know, any bits of code you'd like to see, let me know what you would like to see in the next video. In the meantime, love, hugs, etc. Have a very splendid one.